All right, we are on ellipses. This is 4.04, and you got one more and then the test. So we want to graph the ellipse. So first thing we're going to do is those values underneath x and y there, we're going to square root them because that tells us how far the ellipse is stretched out on that axis. Okay? So right now I'm seeing the x squared has a bigger value underneath. That means it's going to be longer on the x-axis. So we definitely don't want graphs where it's longer on the y-axis. So it's either going to be A or C. So the square root of x squared there, of 16 is 4. And the square root of y, is going to be 2. So we're looking for an ellipse that is stretched out 4 spaces on the y and 2 spaces on the x. And I believe that is going to be from the vertex. And if I'm wrong, it'll tell me I'm wrong. Hold on, let's check. So I believe it's going to be A. So from the vertex, from the center, you should be able to count. We can zoom in. 1, 2, 3, 4. So it should be that one. Oh, no, we're not right. So it's going to be the total length of it. So it's going to be C. So that means along the x-axis, it should be 4. Okay, so 1, 2, 3, 4. So that'll be the one. Yay! Okay. Number 3. It's going to be a super short one. I love it. Okay, here we're looking at a hyperbola. That's going to be this graph. And it says sketch the graph. What I would do, honestly, is go to our friend Desmos and just type her on in. Quickest way to get it done. So we're going to go to Desmos. And we're going to type in 4x squared plus y squared equals 16. Check it out. We have an ellipse. Looks like it's got a length on the y-axis here. They just wrote it in a different format. Notice how this is not equal to 1. In order to see the ellipse formula, so you can real easily read the information off, that has to be equal to 1. But we have Desmos, so we don't need to do unnecessary math right now. So it looks like along the y-axis, it's 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to pick the graph that's longer on the y. Oh, that's going to be D. Don't even need to count it. Isn't that lovely? Isn't she lovely? That's a pretty song. Number 5. Okay. Same deal. Now this one we could real easily read off of there. Okay. Same idea for a center. It's going to be the opposite of what's next to x and y. So the opposite of x is 3. Opposite of y is -2. And it's what's next to it. So something at 3, -2, it looks like it's looking like A or C. These are not 3, -2, because the center is like right there. So it wouldn't be that. And then I'm looking for a graph that's longer on the x-axis because it's got a bigger 16. This one looks like it's longer on the x. This one's longer on the y. So we're going to choose A. Yay! And again, you could graph that one as well. On Desmos, that's what I meant. Okay. Oh, I love this question. So this one, they just want to know which distance is going to be longer. You don't even have to read this stuff. The one that's longer is going to be the value that has the bigger the denominator. So since the denominator of the y squared is bigger, that one's going to be, the distance between the y-intercepts is going to be longer than the x. Yeah. How much longer is the longer distance than the shorter distance? So we're just going to subtract what they are, but first we have to square root them. So square root of 49, so the distance along the y is going to be 7, and the square root of 4, distance along the x is going to be 2. 7 minus 2 is 5 units. Oops. I thought I did. Okay, let's see. Give you an example. What did Jen do wrong? Yup, I did that. Okay. Oh, 2 times that. So we have to multiply by 2 first. That's all it's telling us to do, to account for both of the intercepts. So let's multiply by 2. So we're left with 14 and 4. So we would say 10. We just have to double the distance because we're talking about from intercept to intercept, not just, yeah. So what I did is I just looked at the example and I'm like, oh, I got to multiply by 2. So which of the following is an equation for an ellipse? So ellipses have x's and y's that are both squared, and you are going to have an addition sign in the middle. If you have a subtraction sign, you're dealing with a hyperbola. So I believe we're looking at C. Because if I moved that 4y squared to the other side, I would add it. So that is how I would get them on the same side. So if you have a plus sign in the middle, you have an ellipse. If it's a minus, it's a hyperbola. Yeah. And that is it for that one, friends. Happy learning.